Okay, so in this question here we have p of n is equal to 2 to the power of 6n plus 3 to the power of 2n minus 2. Have to prove it's divisible by 5 for all n element n. So we're going to do for step 1 is test p of 1. So to test p of 1, what we're going to get is 2 to the power of 6 times 1 plus 3 to the power of 2 times 1 minus 2. So you're going to get 2 to the power of 6 plus 3 to the power of 2 minus 2 is 0. So that's going to be 1, and 2 to the power of 6, 64. So 64 plus 1 equals 65. Now 65 divided by 5 equals 13. So hence true for p of 1. Now, step 2 is to assume true for p of k. So we're assuming true for p of k. So p of k equals 2 to the power of 6k plus 3 to the power of 2k minus 2, just replacing n with k. Now, part 3 is test p of k plus 1. Now, to test p of k plus 1, what we gotta do is get p of k plus 1, and it's up to be 2 times 6 into k plus 1 plus 3 times 2 multiplied by k plus 1 minus 2. So what we're going to get here is 2 to the power of 6k plus 6, and we're also going to get multiply that out. And we're going to get 3 to the power of 2k plus 2 minus 2 plus 3 to the power of 2k. Now, what we got to do here is we got to make 2k minus 2 plus 2. So we're going to do 2k minus 2 plus 2 because we want to make up 2k minus 2. We also want this to be 6k. So we're going to get 2 to the power of 6 by 2 to the power of 6k, because we want to make out p of k of it. And then we're going to have 3 to the power of 2 multiplied by 3 to the power of 2k minus 2. So 2 to the power of 6, as we know already, should be 64. So we have 64 multiplied by 2 to the power of 6k. And then we have 9 by 3 to the power of 2k minus 2. Now the general rule is, look at the coefficients, the 9 and the 64, turn 64 into 9 and 55 by 2 to the power of 6k. And what we get is 55 by 2 to the power of 6k plus 9 times 2 to the power of 6k, and then we still have our plus 9 to the power of 3 to 2k minus 2 over here. Now, this is going to be 55 by 2 to the power of 6k. And then we're going to factorize out the 9. And we'll get 9 into 2 to the power of 6k plus 3 to the power of 2k minus 2. Now this here is exactly the same as p of k. So this is assumed divisible by p of k. So it's assumed divisible by p of k. And this part here is 55 is divisible by 5. So then we're on to the proof part of this, or the written part. So hence P of k plus 1 is divisible by 5 if P of k is true. Hence, by the principle of mathematical induction, P of n is true. Okay. So, next question after that. Next question after that is prove that 9 to the power of 4 into 2n minus 5 to the power of n minus 1 is divisible by 11 for all n element n. So, what we get here, guys, is the following. P of n ends up to be 9 to the power of 4 to the power of 2n minus 5 to the power of n minus 1. We test P of 1. So P of 1 equals 9 by 4 squared minus 5 times 1 minus 1. So 9 times 16, or 9 times 4 squared, is going to be 144. 144 minus 5 to the power 0, 5 to the power 0 is 1, equals 143. 143 divided by 11 equals 13. So 143 divided by 11 equals 13. Okay, part 2. Assume true for P of k. And what we can see here is that P of k ends up to be 9 to the power of 4 to the power of 2k minus 5 to the power of k minus 1. Okay. 3. Test P of k plus 1. Now P of k plus 1 is going to be 9 times 4. Now it's going to be 2 times k plus 1, and that's going to be 2k plus 2, and this is going to be 5 by k plus 1 minus 1, which is just going to be minus 5 to the power k. Now, but I'm going to keep it as k minus 1 plus 1 instead. I'm just changing the two of these around. Still the same thing, still 5 to the power k when you cancel them off. So what I got to do here is separate out the 4 squared. So it's going to be 9 times 4 squared by 4 to the power 2k. Okay? And that's going to be 5 to the power 1 by 5 to the power k minus 1. Okay? So what we have next is, so what we're going to do is we're going to multiply the 9 by the 16. So 9 multiplied by 16, I'm pretty sure it's 144. 144. So it's going to be 144 by 4 to the power 2k minus 5 by 5k minus 1. Once again, look at the coefficients, 5 and 144. We're going to change 144 into, what's it going to be?